Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions, equilibrium of a body and Archimedes at rest. This exercise was a previous one in the Breve exams in 2010 third session, third exercise. The title of this exercise is density of a liquid. A solid mass of volume V is equal to 1000 centimeter cubed. So knowing that centimeter cube is not a SI unit of volume, in order to convert from centimeter cube to meter cube, we multiply by 10 to the power minus 6. Then 1000 multiplied by 10 to the power minus 6. Then the volume is given by 1 times 10 to the power minus 3 meter cube. And of density rho is equal to 800 kilogram per meter cube. So these two quantities represent the volume of the density of the solid cube as of the solid S respectively. So knowing the volume of the density, we can directly determine the mass of this cube. Floats on the surface of a liquid whose density is rho prime. So rho prime is the density of the liquid. So here let me do a small sketch. So suppose this liquid is contained in a container. So we don't know the nature of this liquid because we don't know its density. So this is the liquid. Here they didn't mention whether this solid is a cube or a rectangular prism or a sphere. So let's consider it to be a cube. So the shape of the cube in this case doesn't play an important role. So this volume is the total volume of the cube, which is the outer volume of the cube. And it's floating on the surface of the liquid. So because it's floating on the surface of the liquid, so we expect that the density of this solid must be smaller than the density of the liquid. So rho prime in this case must be greater than rho, or in other words, the density of the solid is less than the density of the liquid. Now take G is equal to 10 newtons per kilogram. So we are performing this experiment on the surface of Earth. Moreover, here they are telling me something important, that S is at rest. So we can use at any time in this exercise the condition of equilibrium. Then part A, they are telling me one of the forces acting on S is its weight W, and name the other force. So here, because we have a liquid, in addition to the weight, it will be directly subjected to the Archimedes upthrust force, which acts on the center of gravity of the immersed part. So F will be acting on the center of gravity here, vertically upward like this, because this is the immersed part and this is the center of gravity of the immersed part. Then let's say that the other force is given by Archimedes, upthrust force, F vector. Now part B, write down the vector relation between W vector and F vector. So in other words, they are asking me about the condition of equilibrium. Then always as a title we write at equilibrium. Then how do you apply this condition? Always on the left we write the sum of forces acting on the solid S, and they are given by the weight and the Archimedes upthrust force F vector, and on the other side we write the 0, and we don't forget the vector because this is a vector equation or a vectorial equation. Now here let me make this side remark, that here because we have a liquid, then this weight, it will be either the real weight or the apparent weight. But always when we consider the weight and the condition of equilibrium, we always mean the real weight and not the apparent weight, because the real weight is the force acting on the solid S. Now moving F to the other side of this equation, we'll have that the W vector is equal to minus F vector. So this is the solid S. What does the first equation tells us? That both forces, the effect of the both forces acting on the solid S, cancel each other to give us the 0 vector corresponding for the condition of equilibrium. Whereas the other equation tells us that both forces have same line of action, the minus sign for the opposite direction, and same magnitude. Now this is the vector relation. Now in number 2, calculate the mass m of S, deduce the value of W of its weight W vector. So we need to calculate the mass m of S. We cannot calculate the mass using mass is equal to weight divided by G, because we will use this later in order to determine the value of W. However, here, because we have the volume of the cube, which is given by 1 times 10 to the power minus 3, and we have the value of rho, which is given by 800, we know that the density, mass, and volume are related via the following formula. Knowing that we are interested in determining the value of m, constructing the triangle of this formula here, because we have divide, then rho will be at the bottom, m at the top, v here. We are interested in determining the value of m. Then m is given by density multiplied by volume. So m is equal to density multiplied by volume. Now the density is given by 800 in the SI. The volume V is given by 1 times 10 to the power minus 3. Plugging this on the calculator, it will give us 0.8. Since both density and volume are in the SI, so the value of m will be in the SI, which is kilograms. Then the mass is given by 0.8 kilogram. Now on the same part, they are telling us to deduce the value W of its weight W vector, and by deduce it means that we need to use the previous part. In the previous part, we have determined the value of m, knowing that m and W are related via the following formula, that the weight is equal to mass times gravity. No need to construct a triangle, because this is the quantity that we want to calculate. The value of m that we already calculated is given by 0.8, and the value of g is given by 10. Now plugging this on the calculator, the value of W is given by 8. Since everything in the SI, so the value of W will be in the SI, which is in newtons. Then the weight is given by 80 newtons. And I repeat that this represents the real weight. So for example, if we suspend the solid S to a spring balance in air, then this will be the indication of the spring balance. Now number 3, determine the value of the force exerted by the liquid on S. And here, so they are not referring to the force as the Archimedes upthrust, because they already asked us in part 1.a, part A, to name the force. So here they are referring to the physical definition of the force, which is the force exerted by the liquid on S, which is the Archimedes upthrust. Let me make some space. Now we are in part 3. In the previous part, we have determined the magnitude of the weight, and in part 1b, we have determined the vector relation, which is given by W vector is equal to minus F vector. And this equation tells us that both forces have the same magnitude. So in magnitude, then here we drop down the vector and remove the minus sign, but we know that the value of W is given by 80 newtons. Then the value of F is given by 80 newtons. So F is equal to 80 newtons. Now in number 4, knowing that the volume of the emergent part of S above the surface of the liquid is V1 is equal to 200 centimeter cube, deduce the value of rho prime. So here, this part is tricky. They are telling us that the volume of the emergent part of S above the surface of the liquid is V1 is equal to 200 centimeter cube. So the volume of the emergent part. What does the emergent part represent? This is the emergent part. So they are giving us this volume. So let's say that this is V1. So V1 is given by 200 centimeter cube. Knowing that centimeter cube is not a unit of volume, in order to convert from centimeter to meter cube, centimeter cube to meter cube, we multiply by 10 to the power. So from centimeter cube to meter cube, we multiply by 10 to the power minus 6. Then let me write here that the volume V1, which represents the volume of the emergent part, is given by 200 centimeters cube. In order to convert from centimeter cube to meter cube, we multiply by 10 to the power minus 6. Then the volume of the emergent part is given by 0.2 times 10 to the power minus 3 meter cube. Now we need to deduce the value of rho prime. What does rho prime represent? It represents the density of the liquid. We know, so by deduce it means that we need to use the previous part. We know that the value of F and rho prime are related via the following formula. That F upthrust is equal to the density of the liquid times the volume of the immersed part times G. Now we are interested in determining the value of rho prime. Now constructing a triangle. Here, because we have multiplied and F upthrust will be at the top, rho L, Vi and G at the bottom, we are interested in determining the value of rho prime, rho L, which is denoted by rho prime, which is given by F upthrust, which is denoted by F, divided by Vi multiplied by G. Now we already know the value of F, which is given by 80 newtons, and we know the value of G, which is given by 10 newtons per kilogram. And this is the tricky part, that we need to determine the volume of the immersed pi Vi. Knowing that the given is the emergent volume, which is given by 0.2 times 10 to the power minus 3 meter cube. And we know the total volume of the cube to be V is equal to 1 times 10 to the power minus 3 meter cube. So we know the volume of the emergent part. So this is the emergent part. And we know the total volume of the cube, so it's left to determine this volume, the volume of the immersed part. Knowing that, let me write here, that the total volume of the cube is given by the volume of the emergent part, which is denoted by V1, plus volume of the immersed part. And we are interested in determining the volume of the immersed part. So the volume V is given by 1 times 10 to the power minus 3 in the SI. So this is the value. And the volume V1 is given by 0.2 times 10 to the power minus 3 plus Vi. So this is the volume of the emergent part. So what's the type of this equation? This is a linear equation and one unknown V1. How do we solve this equation? We put V1 on one side and all the other numbers on the other side. Then V1 is given by 1 times 10 to the power minus 3 minus 0.2 times 10 to the power minus 3. Now plugging this on the calculator, it will give us 0.8 times 10 to the power minus 3. Since both this value and this value are in the SI in meter cube, then the volume V1 will be in meter cube. Sorry, this is Vi and not V1. So Vi is given by 0.8 times 10 to the power minus 3 meter cube. Now after we have determined the volume of the immersed part, we can get back to the question and determine the value of rho prime. Then the value of F, which is given by 8, divided by 0.8 times 10 to the power minus 3, multiplied by the value of G, which is 10. Plugging this fraction on the calculator, it will give us 1000. Since everything in the SI, so the value of rho prime will be in the SI, which is kilogram per meter cube. Then the density rho prime of the liquid is given by 1000 kilogram per meter cube. Now comparing both densities, we already have the density of the solid as given by 800, and now we have that the density rho is given by 1000 kilogram per meter cube. And notice that the density of the solid is less than the density rho prime, as we expect, because the solid S is floating on the surface of the liquid. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.